Okay, here's another example. We have the integral of x sine x dx. If integration by parts is going to work, we're going to have to find a part that we differentiate and a part that we integrate here. So I've got basically the product of x and sine x. I can differentiate both and I can integrate both, so how do I decide which one for which? So, well, if you think about differentiating or integrating sine, the derivative of sine is cosine, the integral is minus cosine. So you get about the same thing no matter which way you go with sine. But x, the derivative, is simpler, it's 1, but the antiderivative is more complicated, 1/2 x squared. So for that reason, I'm going to choose to try to differentiate x, and that means I'm going to have to integrate the sine x. So I differentiate the x, I get 1, I integrate the sine x, and I get negative cosine x. So remember, the pattern is that I get to trade this product, I get to trade the integral of this horizontal line for this product minus the integral of this horizontal line. To keep track of it, I could write a little plus sign out here. That would remind me that I've got to do plus the integral of that and minus sign here to remind me to subtract the integral of this horizontal line product. Okay, so we end up getting here, that's a stray mark as part of that. Okay, so we end up getting here negative x cosine x, and then minus the integral of minus cosine x dx. Okay, so we get minus x cosine x. If I pull that negative through, I get plus the integral of cosine x dx, but the integral of cosine x dx is sine x plus a constant. Now I can check here by differentiating. The derivative of negative x cosine x, of course, requires the product rule. So the derivative of negative x is negative 1 times the cosine of x, and then the derivative of cosine x is negative sine. So negative x times negative sine gives positive x sine x, and then the derivative of sine is cosine. Notice there's a plus cosine and minus cosine. They cancel, so we get x sine x, which is what we were hoping for, right? We're trying to find the function whose derivative is x sine x. So that means we've found the answer. There's the antiderivative of x sine x. Here's one that's very similar. Notice it's a little bit more complicated. Again, I'm going to have to choose part to differentiate and part to integrate. And if I differentiate the x squared, it will get simpler, so I'll make that choice. And let's see, if I do differentiate that, I get 2x. Integrating again gives me minus cosine x. Remember, I'm going to have to take this product and subtract the integral of that horizontal product. So I get negative x squared cosine x minus the integral of negative 2x cosine x dx. Now look at this, I still can't do this horizontal integral, but I can see that I could do integration by parts to get that integral done. In fact, I have negative 2x and cosine x. This is perfect here. See, that product is right there. So if I want to apply integration by parts again, I just have to differentiate this one more time and integrate that one more time. But remember, we were subtracting this integral, so there's an extra negative sign. So if I differentiate this 2x, I get 2, and if I integrate the negative cosine x, I get negative sine x. Now, if I was just trading in this 2x minus cosine x, I traded in for this product minus the integral of that, right? But I actually have a negative sign already in front of the integral from here when I was integrating the first time I applied integration by parts. So now I flip this to a plus sign to take account of that negative that's already there. We did integration. Every time we do integration by parts, it throws an extra negative in front of the integral that remains. So you can just look right at my table here. This integral is going to be traded for negative 2x times negative sine x. That's going to be plus 2x sine x, and then plus this integral. So plus the integral of negative 2 sine x dx. Now, this integral is simple enough that I can finish it off, right? That integral is 2 cosine x plus c. So I'll just do that. Negative x squared cosine x plus 2x sine x. And then this integral we said was 2 cosine x plus c. There we go. Now, to check it, we would have to differentiate it. Let's go ahead and do that. Make sure we've got the right answer. So if I differentiate this first part, I get negative 2x cosine x, and the derivative of cosine is negative sine, so I get plus x squared sine x. And then to differentiate this, it's going to require the product rule. I get 2 sine x, and the derivative of sine is cosine, so I get plus 2x cosine x. And then finally take the derivative of this, which is minus 2 sine x. Notice the minus 2 sine x cancels the plus 2 sine x. The plus 2x cosine x cancels the minus 2x cosine x. And so we get x squared sine x. It means that our answer is correct. Now, this is an example of using integration by parts multiple times. If you'll just draw this table where one column is what you're differentiating and one column is what you're integrating, it will keep it straight. In fact, you notice back here at this stage we could have used integration by parts again because we had a 2 and we had a negative sine x, just like we already had in the bottom line of our table. So integration by parts says you can trade the integral of this horizontal product in for this diagonal product minus the integral of the next row down. Let's see, if I differentiate the 2, I get a 0. If I integrate negative sine x, I get cosine x, right? So the sign will flip again, so we could have just said, oh, that's going to be 2 cosine x minus the integral of 0, but the integral of 0 would just be a constant. So this would have popped out the answer very quickly for us.